Your engine is one bad decision away from a bill you can't afford, and it starts with a bottle you probably already have in your garage. Some of the most popular additives sold in auto parts stores right now have been tied to clogged oil passages, corroded bearings, and full engine failure, yet millions of drivers still buy them every single month without knowing what's actually inside. In the next few minutes, you'll learn exactly which 7 additives mechanics warn you to avoid, the real chemistry behind why they fail, and what they end up costing you in repair bills. Stay until the end, because the last one on this list looks the most harmless on the shelf and does the most damage inside your engine. Number 7 is the solvent-based engine flush, usually priced under $15 and marketed as a 5-minute fix for years of built-up sludge before an oil change. In older or high-mileage engines, that sludge is often the only thing holding worn components together, and dissolving it all at once sends loose debris straight through your oil system in a matter of minutes. Owners have reported oil pump drive shafts twisting like licorice under the strain, and bearings reduced to metal flakes at the bottom of the pan within days of a single flush treatment. There's also a ring seal problem in older engines, where carbon buildup inside the cylinder walls actually helps the piston rings seal properly, and a flush washes that build up out, leading to blow-by and rising oil consumption. NHTSA complaint records include cases where a flush preceded total engine failure, with rebuild quotes running $4,000 to $7,000 depending on the vehicle. Your verdict: skip the flush on any engine past 100,000 miles and change your oil more frequently with quality oil instead. Number 6 is the Thick Viscosity Booster, sold around $10 a bottle and marketed as an instant fix for oil consumption and engine noise in high-mileage vehicles. It appears to work for a few weeks because it masks worn piston rings and leaking valve seals rather than repairing the underlying mechanical problem. In cold weather, the thickened oil congeals almost like glue, your oil pump struggles to circulate it fast enough on startup, and dry starts become routine every single morning. Modern oils are engineered with a specific additive package, and pouring in a heavy thickener disrupts that balance, causing the oil to foam under high heat and fail under stress over time. Owners who used it long-term report the same pattern: quieter engine for a month, then sudden bearing failure costing $3,000 to $5,000 to fix. Your verdict: a thickener hides a mechanical problem, it never solves one, and the bill always comes due eventually. Number 5 is the classic thickening treatment sold in its familiar blue bottle for under $10, promising reduced wear and quieter operation since the 1970s. The Federal Trade Commission has taken formal action against this exact product twice, in 1976 and again in 1995, both times for false claims about reduced engine wear. Independent analysis found the blue bottle is over 200 centistokes in thickness, and adding 1 full bottle to 5 quarts of 5W30 oil can push its actual viscosity closer to a 15W40 without you ever choosing that thickness. In modern engines with tight tolerances and variable valve timing, that extra thickness restricts oil flow to critical components exactly when they need consistent pressure. If your engine genuinely needs thicker oil, buy the correct viscosity grade instead of guessing with an aftermarket additive. Your verdict: this product does not deliver the protection its label claims, and 2 FTC rulings prove it. Number 4 is the extreme pressure additive built on chlorinated paraffin, roughly 51.5% by formula according to its own patent filing, originally engineered for industrial metalworking machinery. Chlorinated paraffins perform well in laboratory load testing equipment, but under sustained engine heat these compounds can decompose into hydrochloric acid, and that acid attacks bearing surfaces and other soft metals from the inside out. The patent itself acknowledges these additives are highly corrosive and were previously considered unsuitable for internal combustion engines before reformulation. The FTC sued the manufacturer over unsubstantiated claims of reduced engine wear, extended engine life, reduced corrosion, and prevention of breakdowns. Mechanics who've inspected engines run on this additive long-term have found bearing corrosion patterns consistent with acid exposure rather than ordinary mechanical wear. Your verdict: an additive that can turn into acid inside your engine is not worth the risk at any price point. Number 3 is the PTFE-based friction reducer, often sold around $25 a bottle and marketed as a permanent coating that eliminates metal-to-metal contact for the life of your engine. Independent testing, including work referenced by NASA researchers, found PTFE particles do not bond to hot moving metal surfaces the way the advertising claims. They simply clump together and circulate through your oil system instead. Your oil filter catches some of that clumped material, but the rest settles out under heat and pressure as a gummy white varnish that coats vital internal components and restricts oil flow through narrow passages. DuPont, the very company that manufactures Teflon, has publicly stated that PTFE is not useful or safe as an ingredient in internal combustion engine oils. Modern motor oils already contain advanced anti-wear packages, and adding PTFE on top disrupts the carefully engineered balance rather than improving it. Your verdict: this product clogs more than it protects, and the manufacturer of its own core ingredient says so directly. Number 2 is the zinc-only additive, popular with owners restoring older engines with flat tappet camshafts that genuinely do need higher zinc and phosphorus levels than modern oils are legally permitted to contain. The problem isn't the zinc itself, it's the chemistry around it. Adding zinc without a detergent package to balance it lets acidity rise steadily inside the crankcase over repeated oil changes. That acid goes to work on bearings and other soft metal surfaces, and mechanics who've torn down engines treated this way have found where patterns that look more like corrosion than standard friction damage under a microscope. Products that pair zinc with a calcium-based detergent package avoid this problem entirely by neutralizing the acidic byproduct as it forms. Newer research has also linked decreased zinc levels in modern oils to increased piston scuffing in older flat tappet engines specifically. Your verdict: never add zinc alone. Only use a zinc additive that includes detergents to keep the chemistry balanced and stable. Number 1 is the multi-purpose treatment, usually priced around $12 and marketed as a single bottle that cleans your engine, boosts your mileage, quiets your noise, and extends your engine's life all at once. A single product claiming to solve every possible engine problem simultaneously is a claim worth questioning before it ever touches your oil. In FTC testing of one major product in this category, treated oil produced 185.7 milligrams of bearing where using the standard CRC38 test compared to 74.1 milligrams for untreated oil, more than double the measurable damage. The FTC also found the manufacturer had edited that bearing corrosion data out of its own infomercials and website marketing materials before publishing the results publicly. Independent lab analysis of the product's 3 separate formulas found each one was essentially tinted mineral oil with no active chemical additive package at all. Your verdict: an additive that promises everything is protecting nothing, and the lab data proves it beyond dispute. Now you know exactly which additives to avoid and why, backed by FTC rulings, independent lab testing, and documented owner reports rather than marketing claims on a bottle. Check your oil for the API Starburst certification mark before you buy anything. It's the fastest way to confirm your oil meets current engine protection standards for low-speed pre-ignition and modern engine tolerances. Subscribe so you don't miss the next video breaking down which additives actually work and which ones mechanics genuinely trust. Drop a comment letting me know where you're watching from.